Okay, so now we're going to look at trig functions. I guess you could say for single values. Well, not even values, more like identities. Better yet, trig equations for a single trig function. That's better. A little more of an accurate title. For a single trig function. And really, we're going to solve these exactly the way you would solve any type of equation. Okay, so let's say if 0 is less than or equal to theta is less than 2 pi. So theta is somewhere between 0 and 2 pi. So let's say we want to find theta for 6 sine of theta plus 6 equals 9. Okay, so if we have our 6 sine of theta plus 6 equals 9, we just subtract 6 from both sides, which is 6 sine of theta equals 3, which means our sine of theta will equal 3 over 6, which is 1/2. Okay, so we just have to find what values of theta equal 1/2. Okay, so you want to remember, sine of theta is positive. In quadrants 1 and 2. Okay, so all of our values of theta has to be in quadrants 1 and 2. Okay, now if it come out to be negative, then that would have changed it up. But because it came out to be a positive 1/2, we just have to find those values where it's true there. Okay, so sine of pi over 6 equals 1/2, and sine of 5 pi over 6 equals 1/2. Okay, so that means theta is true. I mean, not theta. This is true for theta equals pi over 6 and 5 pi over 6. Now remember, once you find out that theta equals, well, theta of pi over 6 equal 1/2, once you go to quadrant 2, remember you have to use your reference angle, which is pi minus theta, so it'll be pi minus pi over 6, which gives you your 5 pi over 6. So it's found by using the reference angle for quadrant 2. Pi minus theta. All right, so any questions on that one?
So we have 2 answers?
Yep, you have 2 answers on that one. So whenever they give between 0 and 2 pi, it can sometimes be true in just one quadrant. Sometimes it'll be true in more than one. All right. Okay, our next example. Oop, everyone's still writing. All right. Okay, so let's say if we know that our theta is between 0 and 2 pi, we want to find theta for negative 14 sine of theta plus 2 equals 16. Okay. So just like before, we want to isolate our sine of theta. So negative 14 sine of theta plus 2 equals 16. Uh-oh. Subtract 2 from both sides. So you have negative 14 sine of theta equals 14. Divide both sides by negative 14. Sine of theta equals negative 1. So between 0 and 2 pi, we only have one value of sine of theta that equals negative 1. This is true only when theta equals 3 pi over 2. Okay. So you don't really have to worry about the quadrant there, because there's only one value that would make that one true. All right. So any questions on that one? Okay, so let's say, for example, if theta is between 0 and 2 pi, find theta for 1 minus 7 cosine of theta equals 8. It's honestly still snowing? Man. Thought it would have stopped by now. Okay, so just like before, we solve for our cosine. Okay, so 1 minus 7 cosine of theta equals 8. Subtract 1 from both sides. You have negative 7 cosine of theta equals 7. Divide by negative 7. Cosine of theta equals negative 1. Okay? So just like with this one, it's only true for one value, and that's when theta is equal to pi. Okay? So that would be your answer. All right. Any questions on that one? All right. Anyone's still writing? All right, so what if we had, for example, want to solve for theta in the interval from 0 to 360 degrees, which is the same as 0 to 2 pi, but just in degree form, for negative 5 square root of 3 secant theta minus 8 equals negative 18. Okay. So again, we just solve for our secant theta. Negative 5 square root of 3 secant theta minus 8 equals negative 18. Add 8 to both sides. So you have negative 5 square root of 3 times secant theta. Nope, that should be negative 10. Oh, I was about to put that right. Okay. So we divide both sides by 5 square root of 3. Secant theta equals negative 10 over 5, negative 5 square root of 3. Which means our secant theta is equal to 2 over square root of 3. Okay. Now you can solve this one kind of one of two ways. You can try and go back and find out where your theta is equal to 2 over square root of 3. Or you can remember that secant of theta is just the reciprocal of 1 over cosine of theta. Okay. So secant of theta equals 2 over square root of 3. It would be true for cosine of theta, which is square root of 3 over 2. Okay. So both of those will have the same theta. Okay. So we know this would be true for theta equals square root of 3 over 2, well, not square root of 3, 330 degrees. Okay, and we know that because our theta would be positive in quadrants 1 and 2. Nope. 1 and cosine. 1 and 4, sorry about that. Had to do my little rhyme in my head. Single cows can't, blah, blah, blah. So cosine of theta is positive in Q1 and quadrant 4. So secant of theta is also. So really, this is all you would need. And once you kind of convert it to cosine, you don't have to remember the secants. Just remember that one's the reciprocal of the other. All right, so any questions on that one? All right. Leave that up there for a little bit. Oh, ran out of paper. All right, I'm still writing. All right, leave that up for a few more seconds. Okay, so let's say for our next example, let's say we want to solve for theta. The interval from 0 to 360 degrees for 5 cosecant theta minus 7 equals negative 2. Make that negative a little deeper. There we go. Okay, so just like before, we're going to solve for our cosecant theta. Minus 7 equals negative 2. Add 7 to both sides. So 5 cosecant theta is going to equal 5. If we divide both sides by 5, our cosecant of theta is going to equal 1. Oh, if you wanted, you can make it 1 over 1. I'll do that just to... The only reason I did that is because the reciprocal of cosecant is sine. So if you just flip it over, that's why I made it 1 over 1. You could have left it as just 1 and it would have been the same. Okay, so remember, cosecant of theta is 1 over sine of theta. So if it's true for cosecant of theta equals 1 over 1, which is 1, it's also true for sine of theta, which is just the reciprocal of that one. Okay. So we know that sine of theta equals 1 for at 90 degrees. Actually, you can write an arrow for both of them. It's true when theta equals 90 degrees. All right. So any questions on that one? All right, so I'll do one more example. And I'll let you out of here. Try to keep the pre-test class periods as short as possible. All right. Just enough so we won't fall too far behind. All right. Yep, English still writing. Okay. All right, so let's say, for example, actually, I'll do this one. Okay, so let's say we want to solve -2 times square root of 3 times cotangent of theta plus 3 equals -3 on the interval from 0 to 360 degrees. Okay, so once again, we just solve for our cosine of theta, cotangent of theta. So -2 square root of 3 cotangent of theta plus 3 equals -3. We subtract 3 from both sides. So we have -2 square root of 3 cotangent of theta equals -6. Okay, so if we divide both sides by -2 square root of 3, cotangent of theta equals 6 over 2 square root of 3. 6 and the 2 cancel each other out, so you end up with 3 square root of 3. And this one can be simplified a little bit more, because 3 is equal to square root of 3 times square root of 3. So that means our cotangent of theta, that's 3 over square root of 3, is actually square root of 3 times square root of 3 over square root of 3. Okay, these two cancel out, so your cotangent of theta is equal to square root of 3. Okay, so remember that cotangent of theta is just the reciprocal of tangent of theta. Okay, so if it's true for tangent of square root of 3, then it's also true for tangent of theta, which is 1 over square root of 3, which is square root of 3 over 3. Okay, so we know these are going to be true. Theta equals 30 degrees. And since this is positive, it's going to be positive in quadrant 1 and quadrant 3. So in quadrant 3, it's going to be theta equals 210 degrees. Okay. Let's say tangent of theta. Actually, I'll write tangent and cotangent. Tangent of theta and cotangent of theta are both positive in quadrant 1 and quadrant 3. Okay, so this one we had to use the reference angle from the third quadrant. All right, so any questions on that one? All right, let me make a little sub note here. Using the reference angle from quadrant 3. Okay, so any questions, or everybody's okay so far? All right, so we'll go ahead and stop there. Okay, if you have any questions as far as anything that's unclear that's going to be on the test, feel free to hang around and ask away. If not, I will see you on Wednesday.